So we're here to talk through this Maxi Loop by Murat Can Tonta. It has a 4T's theme, which you can see through the large patterns of the grid. It's dividing each region actually into 2x4 rectangles in the T shape. And those rectangles have some interesting constraints, some of them as large as 5, so a majority of cells will be in one region, some very small like this 3. And remembering the key thing that this is a style where every cell of the loop is used. Start of the puzzle is usually marking in corners and then seeing cases like this cell here on the T, that if we came into this from below, we now have our 3 loop sections already used, and except for dodging the whole puzzle and going outside of the grid, we're not going to find a valid way to fill in cells like that. And so a shape like this can go in and get us started. One thing you'll see, but it actually works on both sides of the grid, like there's an easier way to recognize how this 3 works as a big box, but I want to call attention to it on the other side, and the same sort of logic can work. Notice the key part of a cell like this, and the reason this is a key cell is that if it's crossed by the loop, we now have 2 loop segments in, but neither of these segments is near a border. This has at least one more cell to go to get to a border. This has one more cell to get to a border. We'd have a total size of 4. And so in a group like this 3, we can never use this cell. And that's tied to both the size limits of this and just how parity works in the grid. And so at the start, we can put in effectively these shapes, and these 3's have to immediately escape the grid. And that puts this in. And the same is true down here, but you'll run into it more easily because you'll see this loop has to avoid an end. But now that we're here, we've got one more cell to go before I have to escape the region. So I have to come up and escape, and that comes over here. This 3 has to quickly turn. This has to turn. In this region with the 2's, wherever something comes into the grid, it could go immediately out, but when it's going through a cell, for instance, this has to go through a cell, it will always have to turn in the next cell to get outside through a border. And in this case, coming up and getting to a border is valid, but going to the right and coming down will close the loop too soon. This corner, just like up above, has to be an efficient 3. This comes in like so. And so I think that's valid fulfillment for this lower left section. We can now come back up to this T. This T had a particularly large value of a 6, and this has 9 total cells in it. So notice that the 6 will always come through the stem of the T. There are only 5 cells up top, so if we did not go through this edge, we would not never get a 6 large group. If this is coming through the stem, it can take as many as 4, 5, 6 cells, so it always takes these. And we should now be able to see a reason that this edge is particularly important to use. Notice that if we do take it, we've created a new corner here, which creates another corner as it goes, and this is going to keep turning out and now is quite large compared to what it can be. And so a thing to note in Maxi Loops often, because you're using all the cells in the puzzle, is where you're going to create a corner that creates another corner. In this case, creating a corner to work into a corner is an issue. And so instead, this comes down, these loop ends keep dodging each other, still dodge each other. This comes over like so, this comes over here. We have to figure out a valid way to make this work, but one thing to see is that if we don't cross this edge, we're not going to have a valid 2 shape for this puzzle. And that's another way of actually saying that in any cell like this, we have to use 1, but we have to use this border. If we use just these 2 edges, we'd have an issue. So we can actually, another thing we could have done at the start of the puzzle is mark these ends in for sure out of the 2 rectangle, because we can only form 2 large groups in doing this. So this now is 5 large, this makes it 6, this coming down here takes 3. If this came to this cell, I'd already have used 4 cells with 4 remaining. I'd never get to a 5 large group, so this comes to the right, this comes down. It now is the 5 and has to immediately exit. We get these marked in. Coming over to the right again, we have the start of this shape, this coming through. We still don't have a 4 in this region, so we must always draw that. That puts in this corner. This comes in like so. This comes in here. This edge is always crossed. If it weren't crossed, we'd form too large a group in the grid, but now whichever way this goes, we form a 4, so it looks like we've completely validly packed this shape. I'll just close these loop ends so we don't make too many loops, but I think this is a good stage for the puzzle here. The next thing I now want to show you is another kind of deduction which we'd started at the start, which is the importance of this central edge, and in particular for this 5 rectangle, this 2x4 with a total count of 5. The reason this edge is key is just how we're going to be forming a 5 large grid with parity, and if we don't take that edge with anything, then we're going to have this shape of 2, 3 sections forming, but now that's forming a 6, which is too large, and any of these can only grow up to be size 4. And so there's no way to get a 5 into the grid if we don't cross this boundary. And now another thing to see is that we use one but not both of these other boundaries for sure. If we don't use either of them, we're forming a group of size 4, which is going to add into groups of size 2. That's no good. So we always use one of these. And the place that you should see is a little more constrained is if this has to turn over here. So let's consider this option where we don't have the 5 coming through that space, instead it's coming through this space. And if that's the case, then what happens is these edges come through, we have to dodge here, and we then have to dodge here. But when we draw this, we've now formed a 6 in the grid. And so at least as I was running into my solution path, working through the puzzle, it was seeing that to form a valid 5 shape, I have to come with this kind of pattern, with a pattern that's coming through this edge and not through this edge. That puts in this in the grid, this comes across, this bends, this can't take this to form the 5, it has to come up here to form the 5. And I think there's probably a way that once we know that one of these edges coming in is for the 5, that we have to use an edge that's a checkerboard pattern of cells away for the other one. And so I think you can force that the last edge of the 5 is through one of these 2 middle cells, and that works with this edge pretty powerfully. Anyway, we've marked this part of the loop in the upper right. This closes over like so. This has to come down and not touch this corners. If this came in here, then we would have an issue where we need to form a 5, but we also have these loop ends coming. So this doesn't work. This works. This comes over. We now have 4 cells, so this has to quickly come up. This comes up. This comes up. This will be the 5, and these just have to directly connect. Otherwise, it would be too many cells, and marking the last cells into the loop completes the puzzle. So a pretty tricky challenge. It uses a fair amount of Maxi Loop type deductions, both how do we use all the cells, how do we avoid particular corners, and how do we hit the key numbers for these regions. The odd size regions were pretty hard, and the 2x4 rectangles, these 5s were particularly key shapes, but even just getting the 6 and this T and keeping these 4s valid, like these different things, we shifted throughout the puzzle to use almost all the values and all the shapes pretty well. So really great puzzle from Murat. Hopefully you got something out of the solve, and if you enjoyed this style at all, please try out the book Loop Variety Collection coming out with this and the other variations from the week this Sunday. Thanks, we'll see you soon.